Hello. In this video, we are going to solve a problem involving kinetics and the energy of activation. The enzyme catalase catalyzes the decomposition of hydrogen peroxide as follows into water and oxygen gas. The energy of activation for this reaction under the influence of the catalyst is 7.0 kilojoules per mole. Now, if we have the same reaction, but it is not catalyzed, in that case, the energy of activation, so put non-catalyzed, is 42 kilojoules per mole. Now suppose that this reaction takes place, it is catalyzed at 20 degrees centigrade. Now we want to figure out is at what temperature would the reaction have to take place if it was not catalyzed, so that the rate of reaction would be exactly the same as the catalyzed reaction at 20 degrees centigrade. Recall that the Arrhenius equation tells us that the rate of a chemical reaction is equal to A, the pre-exponential factor, times an exponential, which is minus the energy of activation, divided by R times T, where R is the gas constant and T is the thermodynamic temperature. For later use, it's useful to notice that 7 kilojoules per mole is exactly the same as 7,000 joules per mole for our energy of activation for the catalyzed process. For the non-catalyzed process, the energy of activation is 42 kilojoules per mole, which is the same thing as 42,000 joules per mole. Last but not least, we recall that a temperature of 20 degrees centigrade is the same as 293.15 Kelvin as our thermodynamic temperature. Now, specifically for the catalyzed case, we can write the rate, rate sub cat, is equal to the pre-exponential factor, A, times the exponential, and here we put in the specific energy of activation, which for the catalyzed process is 7,000 joules per mole. And we divide it by the gas constant R, so it's right here, and the thermodynamic temperature, which is 293.15 Kelvin. The rate for the non-catalyzed process is again A. We're assuming that for the catalyzed and the non-catalyzed process that the pre-exponential factor is identical. EXP. So now we have the energy of activation for the non-catalyzed process is 42,000 joules per mole. And now we divide it by the gas constant R, and then we have our unknown, which is the temperature for the non-catalyzed process, which here we're going to write simply as T to cut down on our subscripts. The problem also tells us that at some particular temperature T, that the rate of the catalyzed process is identical to the rate of the non-catalyzed process, where we're comparing the rate of the non-catalyzed process at some temperature T, and the rate of the catalyzed process is at 293.15 Kelvin. Next, we can substitute in our specific values from the Arrhenius equation. So here we have A exp minus 7,000 joules per mole divided by 293.15 Kelvin times the gas constant R. And the rate for the non-catalyzed process is A times exponential minus 42,000 joules per mole divided by R times T. To simplify, we exploit the fact that the pre-exponential factor A is considered to be identical in both cases. So we can divide through by A, and we take the natural logarithm of each side. So that simplifies it to minus 7,000 joules per mole divided by 293.15 Kelvin times R is equal to minus 42,000 joules per mole divided by RT. For the next step, simply multiply each side of the equation by the gas constant R, which gives us minus 7,000 joules per mole divided by 293.15 Kelvin equals minus 42,000 joules per mole divided by T, and then we'll take the liberty of multiplying again each side by minus 1, which makes both sides positive. Now we simply multiply both sides by T and by 293.15 Kelvin divided by 7,000 joules per mole, and we get that T is equal to 1758 Kelvin. Now recall that the energies of activation were only given to two significant figures, which means that our answer must have only two significant figures. So that means we round to 1800 Kelvin, which we can also write in scientific notation, which emphasizes the fact that we have exactly two significant figures as 1.8 times 10 to the 3 Kelvin. So it says that to get the same rate of reaction of decomposition of hydrogen peroxide that we get with an enzyme catalase at 293.15 Kelvin, we would have to raise the temperature to 1800 Kelvin to get the same rate without the benefit of the enzyme catalyst. Thank you very much for your attention. Have a good one.